Alright, so we're just going to use the knowledge of continuous random variable to solve some practical problems. Alright, I'll give you a couple of minutes to read example 1 first. So produce, I'll let you do it. Read it rather than me reading through it. Alright. Now, if you look at a question like this, the actually important thing to look at is how are you going to find the equation of the two straight lines. Alright? That is important, the equation of the two straight lines. You know that this is the probability density function. Now, the range is from 2 kilograms to 70 kilograms. So that point there is not 0, that's 2.
Yeah.
That point there is 70. Alright? So when you look at graphs, you've got to be very careful. Refer to the questions. 2 kilograms, not 0. Alright? And then you should be able to find what the gradient of this is and what the gradient of that is. Now, the most sail being approximately 20 kilograms. So it's telling you that the peak here is 20.
Yeah.
Alright? The peak here is 20 because that would be the mode. So therefore, you know that you can work out what K is. You know what 20, that is 20. So using the area formula, half of 70 minus 2 times K equals 1. The area formula of the triangle. So you can work out the coordinate of K. From there, you should be able to work out the gradient and then substitute numbers in to find the equation. Alright? So I'll give you a couple of minutes to find the gradient of both lines and find the equation. So what I'm trying to do is guiding you through step by step how to answer a question like this. Alright, so you should be able to find the equation for this and equation for that. Five guided examples today. So what I've done is I look at the two domains, 2 to 20 and then 20 to 70. What I've done is, I've actually worked everything as a fraction. It really doesn't matter. I like to do this in fraction so that when I plug into my calculator, I use fraction as well, rather than decimal places. Your class pad is powerful enough to take all the fractions, so use fractions. Alright? So if you could work out the gradient, one is 1 over 612, the other one is 1 over minus 1 over 1700. And you can work out the equation. And always write out the probability density function. So you've got it as a piecewise. From there, you should be able to work out your probability. So if you're working out probability between 30 and 40, all right, it's here. You know that all you need is this equation. So you integrate between here and here, 30 to 40. All right? Now, this technique of answering. You could plug in your calculator and you will get 0.2059. You know that the equation is here. Or, the other technique, you can use this to work out what this point is and what this point is, and then use the area of trapezium. It's up to you. If it is calculator section, probably plug that in your calculator. Alright?
Yeah.
Use your class pad. Now, greater than 10 kilograms. Alright, you know greater than 10 kilograms, you need to worry about this area here and that area here. However,
You should do 1 minus.
yeah, just do 1 minus. You know the area under is 1 minus. Instead of doing 2 integrals, you just do 1 minus the integral between 2 to 10. Alright?
Yeah.
When you're answering a question like this, answer it smarter. So anything to do with that, you don't really want to do 2 integration. Sometimes, if it is calculator free section, if you do integration, you might make some errors. All right, and then again the same with less than 55. 1 minus greater than 55. All right, look at the area here. 1 take away that area. That will make life a little bit easier. It's just a technique for answering question that I'm trying to discuss today. So you know how to do it, you know how to do the integration. So if you are given a graph, always look for the equation. Straight line graph, look for gradient first. Before you look for gradient, always look for k first, the highest point. This one is given to you so that you know what the y coordinate is. You could look out k, and then you can work out the gradient. All right, knowing the area is 1. So these are the step by step how you work out question like this. Equation, write out the probability density function, and then use your integration to find the probability. All right. So remember, answering the question, you could think about 1 minus rather than doing 2 integrals. All right, let's have a look at example 2. Example 2, the arrival time of a taxi in a continuous random variable x defined by the PDF below. All right. The taxi firm states that on average the taxi will arrive within 5 minutes. Is this statement true? How do you show that this statement is true? Or false? Yep. So use the expected value because the word on average, all right? Look at the word on average. The word on average is saying that the expected value is within 5 minutes. Is that true? So you need to use your formula to find the expected value. So the question, this sort of question, important is look at what is stated here. It's not that you don't know how to do your expected value. Now you've got 3 different equations, so you need to find the expected value from 0 to 8, correct? So you've got that, 3 regions to look at. This time you really have to do the 3 integration. So integrate between 0 to 5, x times x over 25, which is x squared over 25, and integrate between 5 and 7, x times 1 over 5, which is x over 5, and then integrate between 7 and 8, which is 8 minus x times x over 5. You should be, this potentially is, I think it's a calc, assume.
It's not too difficult.
Yeah. Use your calculator. So you can work that out. I mean, even without calculator, you should be alright, but with the calculator, you work out exactly. The expected value is 4.8 minutes. So the statement is true because 4.8 is less than 5. Alright, work it out. that is one step. The next step is to say that it is true because 4.8 is less than 5 minutes. Always go the next step, always answer the question. You cannot just find the expected value. Alright, example 3 should be quite straightforward. How do you show that K is 333? Now, question like this, alright? Here, if you cannot do this part, go straight to do part B and part C because K is given to you. Alright? If you're not sure how to show that K is 333, go straight to do part B and part C because part B and part C is relying on K and you know what K is. Right? So just make sure that if you got something like that in your exam, if you're not sure about part A and you're already told what the value of K is, you're just asked to show, just use it. So in this case, you should know that by integrating from 1 to 10, h squared over K, the area equals to 1. Alright? You need to be able to do the integration. So integrate h squared over K dh equals to 1. 1 to 10. I will show you how to use some of the calculator a little bit later when you've got similar function that you need to use it a few times. Do a define. This stage, if you could use your calculator, you should be able to work out. It probably doesn't even need a calculator. Alright? This is how you do it. So if you integrate, I should have put down dh here. My fault. There should be a dh. That's better. Gee, I still miss something. I still miss the K. I still miss writing down the K here. Alright, that's better. No wonder it looks a bit strange. Alright. Now, once you've done that, you can sketch. Sketching, just get the shape correct. You really can't, the skills is hard. So it's really hard to work out the scale. So if you start from 1 to 10, that's an important one. Drawing all the way up, knowing that point is 100 over 333. Yep, tan square 100 over 333. That should be fine. All right, that's an open circle here. That is 0 and that's 0. And then you can determine the probability that the water reaches a height of at least 6 meters. So at least greater than 6, you want to look at between 6 and 10. All right? You can integrate from 6 and 10 or integrate from 1 to 6 and take away. It's up to you. I use 6 and 10 and 784 over 999. I use my calculator to do it. It just make life a little bit easier for me, that's all, when I do the solution. And just remember the probability has to be less than 1 and greater than 0. All right. Example 4. So you can see that the time t seconds, that means it didn't say whether it's a discrete or continuous. It has to be continuous because it's time. All right, the question didn't really specify it, but you know that it's a example 4. It should be continuous. Now you are asked to determine the continuous distribution function of t. All right. So the PDF, the density function is given by this. You need to find out the continuous distribution of t. You right? Take a few.
Sick, mate?
Yeah, I don't know. Just today, like I don't know.
Yeah, don't. Hay fever.
Yeah, this shit could be though.
In the middle of winter.
Possible. All right. So this one, you want to integrate from 5 to k. So you actually know 5 over t squared, and you can work out.
Dummy.
That is your ft.
So is this the last thing we need to know before our test?
Yep.
Okay.
I'm not starting anything new until next week.
Okay.
All right. Now, here you can see that
Is this the last question?
1, 2, and 3, you will require to use this function a lot. All right? Have you all got your class back?
Yeah.
All right, I'm going to show you something because it may make life a little bit easier for all of you. Who hasn't got a class back?
He says that all the time, bro. Might make life a little bit easier.
Anyone without a class back?
And it always makes life a little bit
Okay, you
easier.
got it?
Yeah.
You got it?
How do you do piecewise?
You need to use your class
There's
back.
no way you can do piecewise on this thing, bro.
Class back? All of you got class back? Class back?
Yeah.
Got it? Okay. Now, see this function here. All right? What you really want is, in your class back, if you've got to repeat, use it a couple of times. Oops. All right? Go to main. I will just edit clear everything first. Clear all variables and clear all. All right? Make sure you do that. What you do is go to some keyboard, Mat 3. Use define. Use define. Define f. Put that in. That little bit here. F. Then you can define that as fx or fy of whatever. I'm just calling fx. All right. Define fx equals to this. Minus. Oops, I forgot the equal sign. Equals to minus 5 over t, or over x actually, plus 1. All right? And tap execute. Which means when you look at this, you don't have to re-type this all the time. You can just say F3. What is that? Okay, there's no F3 anyway,
Negative.
so
Oh, yeah,
F got to greater than has got to be greater than 5, 6. All right, you got your answer straight away. Or F9. So if you look at the question, less than 7, you're using this a couple of times. So perhaps it is easier to use this define function. All right, especially if you come to the third part. The third part, you've got to work out the puzzle between 10 and 15 seconds and 12 and 10 seconds. Right? Instead of typing it a few times, you might as well do it that way. So if you define it, of course, with your class back, you can work that out as a fraction rather than decimal. Agree? If you use standard, so it doesn't matter. You can do that, and so part 3 is something like this. So if you've got something like this, t less than 12, given that t is between 10 and 15. So you do know that you need to look at the probability between 10 and 12 and then 10 and 15. All right? Now here, see what I've done is I've used F, FD, F6, F7. So if you use the define function, makes life a little bit easier for yourself. Here, you will know that you need to find between 12 and 10, which is F12 take away F10. That bit, F15 take away F10, a little bit bigger. All right? And therefore, you can work that out to be half. With your either class pair or with whatever. I wrote it out step by step, but I actually used the class pair to check my answer. See, if you define using your class pair to define, you don't even need this step.
Because it's 10 to 12.
Straight away you'll find. Yeah, so this bit is it should be something like this, all right?
Yeah,
so you're looking at between 10 to 15, and then you want the
You
person.
just made a mistake in working.
Yep. All right, that bit here, that over the whole lot.
Oh, yeah. Because you have to go from the given.
Yeah.
Where was the mistake in the word?
Now,
First line.
example 5.
Oh, yeah.
Can you read the question, please? Example 5, and tell me what else is in there other than continuous random variable. Binomial. So you've got a situation of two things now. You're combining one, which is the binomial, which is a discrete random variable, and continuous random variable. Two things. Now, in this situation, you have to assume that they are both independent. All right? You have to assume that they are independent events. All right. So, you either buy the nails in a small packet at $1 per packet, or $4 per kilogram loose. So on any shopping day, the number of X of packets sold is a binomial random variable with the number of trials N and the probability of success 0.6. All right. So you know that the packet selling the small packet is binomially distributed and is 8. P is 0.6. Right? And the weight Y kilograms of nails sold loose is a continuous random variable with the density function, which is that one. All right? Now, let's start off looking at A. Find the probability that the weight of nails sold loose on any shopping day will be between 4 kilograms and 5 kilograms. All right? So here you know that the first thing, you don't have to worry about the small packet yet. You're only worried about this Y bit. You need to integrate between 4 and 5 to find the probability that the weight of nails sold loose at that time between 4 and 5 kilograms All right, you need to integrate between 4 and 5. Let's try it, please.
Two x minus 2. It's in brackets.
All right, I highlighted those. So what I've done in answering this question is I highlighted two different things. A binomial random variable and also the continuous random variable, two things. So I could do a differentiation. Now, the next one is the hard one. All right, how would you find the expected value of the return or the money received by selling the nail?
Just do expected value of one and then expected value of the other.
Yes, that's right. So you need to look at the expected value of the packet, the small packet,
You add the
and the
small
expected
one.
value of the 4 to 5 kilograms. All
Is
right,
that
two
average?
things. So expected value of the binomial random is n times p. That's all. So it's 4.8, and the expected money received is $4.80.
Yeah.
And then the other one, you've got to use your integration.
Yep.
Integrate between 1 to 6, y times 2y minus 1 over 25.
Yeah.
Right? So that is how you could do it. So you know the expected value of x, expected value of that, y. So therefore expected money received. $1 times ex and
Yeah.
4 times ey.
Yeah.
So the expected value, the average, on the average, the shop will have $22.13.
That's shit.
All right?
That's terrible.
Yeah, they're probably losing money by the second. Is that right?
All right, that's all I have
Yeah.
for you today, and there are some questions in Google Classroom for you to solve.